Well, hi everyone. All right, let's go into these practice tests here. Um, and do the original one, the one that you had for um, what day was this one? For Wednesday. All right, so we're going to let f of x equal 2x cubed plus 4x squared minus 2x plus 3, and use synthetic substitution to find f of negative 2. In this problem, when we're using synthetic substitution, we do not change. When we're finding f of negative 2. Negative 2 stays as negative 2 there. So then we put the 2, the 4, the negative 2, and the 3 down here. Skip a line. Bring down the 2. Negative 2 times 2 is negative 4. 4 plus negative 4 is 0. Negative 2 times 0 is 0. Negative 2 plus 0 is negative 2. Negative 2 times negative 2 is 4. 3 plus 4 is 7. So that tells me f of negative 2 is equal to 7. And if you want to make sure you're doing it right, you can plug the negative 2 in for all these x's and calculate and see if you still get 7. Alright, number 2, given that x cubed plus 3x squared minus 4x minus 12 has a factor of x plus 3, use this to find the other factors. So we're going to actually use synthetic division this time, and if x plus 3 is a factor, negative 3 is a 0. So that's what I'm going to put in the box. So in this case, I did change, remember Crazy House, we're going to change the sign there. So 1x cubed, 3x squared, negative 4x, negative 12. We're going to skip a line and go down 1. Negative 3 times 1 is negative 3. 3 and negative 3 make 0. Negative 3 times 0 is 0. Negative 4 plus 0 is negative 4. Negative 3 times negative 4 is positive 12. That is 0. So that is a good thing. Now this is for x cubed. Now we are x squared here. 0x minus 4. Now, this is a difference of squares factoring. So this is a factor, but we want to factor each factor down as much as we can. And so these are the other factors. Alright, now number 3, it says give the number of positive real zeros, negative real zeros, and imaginary zeros of that function. So I'm going to graph that. 3x to the 4th minus 4x to the 3rd plus 2x squared. Oh man alive. Okay, I'm just going to start over. Okay, you see, it's not the first time you've seen that from me. 3x to the 4th, bring it down, minus 4x to the 3rd, bring it down, plus 2x squared, minus 4x minus 10. Alright, I'm going to graph that. And it looks to me like we might have negative 1. Well, it doesn't even matter. We just want to know how many. That's going to matter on the next page, I think. Number of positive real zeros looks like we have 1. Number of negative real zeros looks like we have 1. A number of imaginary zeros. I'm looking for 4. I have a total needs to be 4. 1, 1. I need to have 2 imaginary zeros in that case. Okay. Now, this one is the same kind of question. So I'm going to go x to the 7th minus x to the 6th minus x to the 5th plus x to the 4th minus x to the 3rd plus x squared, let's use that one, plus x minus 1. I think I got it all in there right. Alright, now this one's a tricky one here because I think we're bouncing here. And I'm going to just check for sure. Calc. I want to see where that maximum is right here. I want to see where that maximum is. So I'm going to come to the left of it, come to the right of it, hit enter. And that means 0 for this calculator. So -1, 0. Okay, so that, I need to keep looking at this. We have that -0, but you remember the bounce? That means it has a multiplicity of 2. And then I see this positive 0, and it looks like it's wiggling through there. That means that has a multiplicity of 3. Remember when we bounce off the axis, it's a multiplicity of 2. When we wiggle through either that way or that way, wiggle through the axis, it's a multiplicity of 3. And that's what it looks like is happening on this positive one here. So I got this positive real 0 counts for 3 because of the multiplicity. This one counts for 2. 3 and 2 is 5. I need 2 more to make 7. All right. Number 5. Give all the exact zeros. So I'm going to make another graph. Let's clear this one. Y equals x to the 3rd minus 6x squared plus 13. Oh, look at me again. All right. X to the 3rd, bring it down, minus 6x squared plus 13x minus 10. All right. Okay. Looks to me like we are hitting. That's hard. Ooh. Okay. Looks like we're hitting 2. I'm going to see if we're hitting 2 or not. I could use that 0 function on the calculator, but I'm going to just see if I get 0 by doing this. Now, notice that's positive 2. I'm putting positive 2 in this. I'm not changing the sign right there. So there's 2, okay, so 1, -6, 13, -10. Bring down the 1. 2 times 1 is 2. -6 plus 2 is -4. 2 times -4 is -8. 13 and -8 make 5. 2 times 5 is 10. And that is 0. Alright, so what we're left with is x squared minus 4x plus 5. We're going to set that equal to 0 to find the other zeros. So we know, I'm going to just keep our zeros up here. we know one of them is 2. The other one is when we take negative b plus or minus square root of b squared minus 4ac, all of that over 2a. So I got 4 plus or minus the square root. I think if you do this, you're going to get negative 4 here over 2. So that's 4 plus or minus, square root of 4 is 2, square root of negative 4 is 2i. 4 plus or minus 2i over 2. I'm going to split it up as 4 over 2 plus or minus 2 over 2i, and that's 2 plus or minus I. So I'll go 2 plus I for the second 0 and 2 minus I for the third. So we have our 3 zeros. One of them is real, 2 of them are imaginary. Alright, let's do the same thing for 6. Y equals x to the 4th minus 9x to the 3rd plus 26x. Oh man, oh man. When did you guys see it? Probably as soon as it happened. X to the 4th minus 9x to the 3rd plus 26x squared minus 34x plus 20. Let's graph that. Okay. I'm seeing, I think, I'm going to hypothesize, we'll find out when we do this, that we got 2, 3, 4, and 5. 2 and 5 as the rational zeros. So I'm going to go 2, and then go 1, negative 9, 26, negative 34, and 20. Down to 1. 2 times 1 is 2. Negative 9 and 2 is negative 7. 2 times negative 7 is negative 14. 26 and negative 14 is 12. 2 times 12 is 24. Negative 34 and 24 is negative 10. 2 times negative 10 is negative 20. And that is a 0. And that is awesome. That's what we want. So we know we're good on 2. Let's see if we're good on 5. Now 5, we're going to use the depressed polynomial. I should write that, what that is. That is from x to the 4th. I'm going to just put the 5 down a little lower. But x to the 3rd minus 7x squared plus 12x minus 10. That's what this one represents. So now I'm going to put the 5, and then I'm going to put these back. 1, negative 7, 12, negative 10. Bring down the 1. 5 times 1 is 5. Negative 7 and 5 is negative 2. 5 times negative 2 is negative 10. 12 minus 10, that's 2. 5 times 2 is 10. Negative 10 plus 10 is 0. Now let's bring this down to x squared. We went from x to the 4th to x to the 3rd, now to x to the 2nd. So we have x to the 2nd minus 2x plus 2 equals 0. That, guys, is not going to factor. So I'm going to go x equals negative b. I'll quit singing. Alright. So that is 2 plus or minus square root of, this is 4 minus, negative 4 again, right? That's 4, and that's 8. 4 minus 8 is negative 4 over 2. So this is 2 over 2 plus or minus, I'm doing stuff that I already did. Go 2i over 2, and that's 1 plus or minus 2i. So I need the 1 plus 2i for the third solution and 1 minus 2i for the fourth solution. Okay, number 7. Write a polynomial of least degree that has these given zeros. Okay, so these are the zeros. These are, and I'll write even f of x equals. These are the factors. X minus 1 goes with this one. X plus 2 goes with that one. FOIL. I get f of x equals x squared first, outside, 2x, inside, negative 1x, and last is negative 2. I forgot to write the square for x squared right there. And then I'll combine those two middle terms, and I get f of x equals x squared plus x minus 2. So that is a polynomial of least degree that has that 0. Alright, now this one, it's a little more involved. If the complex conjugate theorem, if 2 minus I is a 0, then 2 plus I is also a 0. So when I go to write this, I'll have f of x equals x minus 5 times x minus, and I'm going to go 2 minus I for that 0, and then x minus, and then 2 plus I for that 0. I'm going to take another step and write f of x equals x minus 5 times x minus 2 plus I, minus 2, and then minus minus is plus, getting rid of these inner parentheses, and let's get rid of these inner parentheses. And that's going to give me x minus 2 minus I. Alright, now I want to just multiply all this together. I'm going to start, and I would suggest the ones with i's in them, start with those two first. And I'm going to use a box to multiply this out. I go x, negative 2, and I here. X, negative 2, negative I here. X times x is x squared. X times negative 2 is negative 2x. X times I is ix. Negative 2 times x is negative 2x. Negative 2 times negative 2 is 4. Negative 2 times I is negative 2i. X times I, that's negative ix. Negative 2 times negative I is positive 2i. I times negative I is negative I squared. Now, that's negative negative 1. I squared is negative 1. So this is equal to 1. This box is equal to 1. So I have x squared here minus 4x. I want you to notice that those cancel and these cancel. Negative ix, positive ix, negative 2i, positive 2i. And then I have the 4 and 1 making 5. Now, remember, that's what this times this is right here. Let's bring down the x minus 5. I'm going to make another box. Don't forget your equals. And I got x squared minus 4x plus 5. I got x here, negative 5 here. X squared times x is x to the third. Negative 4x times x is negative 4x squared. 5 times x is 5x. X squared times negative 5 is negative 5x squared. Negative 4x times negative 5 is positive 20x. Negative 5 times 5 is negative 25. My final answer on this is f of x equals x cubed minus 9x squared plus 25x minus 25. Okay. So I'm just going to add another, I'm just going to add this to the same video. It's going to be one long video. Sorry about that. You can skip around for what you need and but you can also check all your answers from this video. So let's do this again. We're going to go through everything again. Remember, just the big thing to remember here is -3 on this problem goes in the box. I did not change the sign. I got 1, -4, -2, and 3. We're using synthetic substitution. Bring down to 1. -3 times 1 is -3. -4 plus -3 is -7. -3 times -7 is 21. -2 and 21 is 19. -3 times 19 is -57. That makes -54. So I'm going to say that f of -3 is equal to -54. Which should be right if I didn't goof it up. Alright, now number 2. Given that x cubed minus x squared minus 10x minus 8 has a factor of x plus 2, use this to find the other factors. So I'm going to put -2 in the box this time when I'm dividing by x plus 2, and I'm going to use the coefficients 1, -1, -10, and -8. 1, -2 times 1 is -2. -1 and -2 make -3. -2 times -3 is +6. -10 and 6 is -4. -2 times -4 is 8. So yes, it is a factor because the remainder is 0 by the remainder theorem. So x squared minus 3x minus 4 is what we get when we divide. So it's a factor, but if I can factor that, then I'm going to. So what times what is -4? What plus what is -3? I am seeing -4 times 1, -4 plus 1. So I'm going to go x squared minus 4x plus 1x minus 4. Go x times x minus 4 plus 1 times x minus 4. The GCFs of these parts. I'm factoring by grouping. So x minus 4 is the common part, x plus 1 is the other part, and there's the other factors. Okay, I need to graph to look at number 3 here. Let's see what that gives us. I'm going to clear this. I'm determined to pay attention to the exponent. So x to the 4th down minus 2x squared down minus 5x plus 19. I'm going to graph that. Oh dear. X to the 4th minus 2x squared minus 5x plus 19. Okay. Again, graph. What happens if I zoom out some here? Do I get a glimpse of the graph at all? Oh, I do. And it came down here. Hopefully you won't have to zoom any at all. It's a little easier to zoom, I think, on Desmos. But I don't see any positive real zeros. I don't see any negative real zeros, and I need 4, so they all must be imaginary. All right. standard because I gotta make an oops. All right, I gotta hit another graph. So I've got 3x to the 5th. So everybody, I just want to reiterate, we need to account for 4 zeros because of that power, and right now that's how we're going to do it. So 3x to the 5th minus 8x to the 3rd plus 2x minus 4. Graph that. Alright, so I'm accounting for 5. I think if we look that we are bouncing there, and that's a negative. That negative 0 has a multiplicity of 2. That positive probably has, it's just 1 with a multiplicity of 1. So 1 and then 2, 3. I need 2 more to get 5. This 1 counts for 2. Alright, number 5 and 6. Give all the exact zeros. Gotta graph it again. Y equals x to the 3rd plus 2x squared. Alright, I thought I was going to quit that. I'm not. Doesn't look like. To the 3rd plus 2x squared plus 9x plus 18 graph negative 2. Okay, all I'm seeing is negative 2. Okay, if that is a 0, I'm going to set it up. When you find a 0 from the graph, you put it in the box. We'll go 1, 2, 9, and 18. Let's see if we actually get 0 here. 1 times negative 2 times 1 is negative 2, and that's 0. Negative 2 times 0 is 0. 9 plus 0 is 9. Negative 2 times 9 is negative 18. 18 and negative 18 makes 0. Bring down your x to the 3rd by a power. That's x to the squared. That's 0x. I'm not going to write. Plus 9. And that's equal to 0. Now, when I don't have a b value like that, I like to do this with the problem. So I have x squared equals negative 9. X squared equals negative 9. I'm finding the other 2 zeros. We know, oh, I didn't write that. Let me put that up here. Zeros. We know that we have negative 2. Now we're going to solve this one to find the other 2. I'm going to take the square root. When I take square root of this side, I got plus or positive square root and a negative square root. The plus or minus here. Square root of 9 is 3. Square root of negative 9 is 3i. So 3i is one of them. Negative 3i is the other one. So those are the zeros on that one. Alright, number 6. We got y equals, let me clear this one, x to the 4th minus 18x squared. Alright, this is the last problem that I have to use the calculator on today. X to the 4th, bring it down, minus 18x squared, it's already brought down, plus 12x plus 80. Graph that. Looks like I'm seeing -2 and -4. So let's use -2 first. And it doesn't matter which one you use first, by the way. So I got 1, -18, 12, and 80. Bringing down the 1, -2 times 1 is -2. -18 plus 2 is -20. -2 times -20 is 40. Alright. 1, -8. Oh, okay. There's 0x cubed. I just was seeing I was not going to get 0 here, so that's why I paused. And now I know why. So this is 1, 0, -18, 12, and 80. So, if something like that, you've got to get 0 at the end. If it's not happening, just take a good look at what you have. -2 times -2 is 4. -18 and 4 make -14. -2 times -14 is 28. 12 and 28 make 40. -2 times 40 is -80. And that's giving me 0. So I'm making my list of zeros, and we're good with -2 now. Now we're dropping the fourth power down to a third power. So this is x to the third minus 2x squared minus 14x plus 40. And the other 0 I'm using here is -4. And I'm going to use the 1, the depressed polynomial. 1, -2, -14, and 40. -4 times 1 is -4. -2 and 4 make -6. This is that's positive 24. That is 10. -4 times 10 is -40, and that's 0. And this is x squared minus 6x plus 10. I'm going to set that equal to 0. Let's not forget that we have the -4. We did get 0 on that. And let's use quadratic formula. Now this is a recurring thing. So x equals 6 plus or minus, I think you're going to find 36 minus 40. That's square root of -4 over 2. So x equals 6 plus or minus, square root of -4 is 2i over 2. X equals 6 over 2 plus or minus 2 over 2i, which is 3 plus or minus I. 2 over 2 is 1. So I have 3 plus I and 3 minus I. These are my zeros. Now, for 7 and 8, write a polynomial of least degree that has the given zeros, 2 and -3. Okay, on this one you need to remember if 2 is a 0, x minus 2 is a factor. If -3 is a 0, x plus 3 is a factor of the polynomial. Alright, we're going to FOIL on this one. F of x equals x squared plus 3x, that's outside. Inside is -2x. And last, that's -6. So f of x equals x squared plus x, combine those like terms, minus 6. Okay. This one, -3 is a real 0. This is an imaginary, and imaginaries are never alone. So we got to put in a third 0 of its conjugate, 2 minus I. Now here's where I want you to be real careful again. That's x plus 3. This one we're going to go x minus, in parentheses I'm going to write 2 plus I. This one I'm going to write x minus, and then I'll write 2 minus I for this one. I'm going to write out one more time. I'm going to write this out as x plus 3. This one I'm going to go x minus 2 minus I. Distribute that that minus. And let's do it again. X minus 2 and minus minus is plus I. Let's multiply these two together first. Put the x, the negative 2, the negative I here, and the x, the negative 2, the positive I here. And x times x is x squared. Negative 2 times x is negative 2x. Negative I times x is negative ix. X times negative 2 is negative 2x. Negative 2 times negative 2 is positive 4. Negative 2 times negative I is positive 2i. X times I is positive ix. Negative 2 times I is negative 2i. Negative I times I, that's negative I squared. It's double negative 1, which is equal to 1. 1 is what goes in that box. Okay, so this part, I'm going to come down here away from the box a little bit. I got the x plus 3, and then when I multiplied these together, I have the x squared minus 4x. Let's not forget that those are canceling. Ix and negative ix. Negative 2i and positive 2i are canceling. And 4 plus 1 is 5. And I'm going to make another box. Put x squared, negative 4x, and 5 here. X here and 3 here. And write my final answer here when I'm done. X squared times x is x cubed. X squared times 3 is 3x squared. Negative 4x times x is negative 4x squared. Negative 4x times 3 is negative 12x. 5 times 3, is 15. I'm a little out of sequence here. 5 times x is 5x, but everything's in the right place. So I'm going to write x to the third. That's the only x to the third. Those two combine to make negative x squared. Negative 12x and 5x is negative 7x, and then I've got the plus 15. Alright guys, I hope you've looked at this and get a chance to check your work and make sure you're doing it right, and just have yourselves good and ready for the test.